is now being recorded.
So now I'm on camera, and everything I say can and will be held against me. And okay, so here we go. When I first started down this path, I was going to do a presentation on mobile installations, and Billy informed me that I guess down the road, Todd is going to do something on that order. So I switched it and just made it HF Ops. And we got something in the middle of the screen, Rajesh, but I guess that's normally.
Yeah, I'll get rid of that question.
And so at any rate, I added in HF Ops as a base station and mobile station and some of the similarities. I put some information in here for newer hams. It looks like I have some things in here for older hams. So I guess you can see the, I want to test my pointer, it works. And as you can see, these are some base stations, mobile stations that have some history. The picture up in the upper left, the circuit on it, it said 1919 on the internet. And so if anybody recognizes that car or the true date of that car, shout it out. Okay, I believe that's a 1925 Dodge Brothers Roadster, okay? Now try on the bottom right. Somebody should be able to get that. What is that car on the bottom right? Model A, right. What year?
29.
1930. I had one just like it when I was in university and restored it. However, this could have a 31 radiator in it, okay? So it's a pretty interesting, and I looked up that call sign from the old Boy Scouts there, and that's not in use if somebody knows Boy Scout troop that wants it. And then look at this, you can see a little bit hard to see on the screen. I thought it'd be a little bit larger than that. But at any rate, these are QSL cards. That sign right there says 200W, so I imagine he may be operating at 200 watts, not sure. But look at the size of the speakers in it and that. And just look at the speaker on this Model A. It's kind of hard to see it sitting on the running board. And as is the radio, okay? And then also the antenna is kind of a square wire up there on a wood post. So I found those interesting. So I thought that someone in the third quarter might enjoy that. I don't know why Herb's looking at me, but I guess that was something in there for him. So anyway, and this was one other one I pulled off with, and I think that's where they got the circuit on the other, and this is kind of a reverse image, I think. Otherwise, it's from one of the right-hand car drive countries, but it does say, as you can see up there, 2019 or 1919. 20. Let's get on into the presentation. So, bit slow there, Rajesh. Mine's much faster. Okay, we need to know, we need to stay safe, especially for the newer, younger hams, but it's good for us older ones to remember it as well. So we got electrical safety issues. And one thing I want to point out on this is that you do not need to strike a high voltage electrical line with a conductor to be electrocuted. So what did I just say? That means if you have a conductor and you have an electrical line, it doesn't have to touch. You can get electrocuted. Okay, and how does that happen? Well, that's called the flux theory, and some others know about that. And depending on the voltage in that line, that can jump a certain distance due to the flux theory. And if you're grounded and you have a hold of that conductor, it's not going to be a good scene. So, and house electricity, 110, kills a lot of people a year. So think safety, RF safety. You don't want to have RF burns. And also, in the radio stations, if you're putting out a certain wattage, you need to do a station evaluation if you exceed that. Does anybody know what that is for the 2 meter band? It's the same for the 10, the FCC regulations. 10 meters, 12 I think is the same, and then it starts increasing. That's only 58 watts PEP. So you can learn how to calculate that and do an evaluation. Another thing is really important is lightning protection. It's like me being a golfer. I don't go golfing during the lightning storm, nor do I have my antennas online during a lightning storm. And later in the presentation, I'll show you how I handle lightning. All right? Back to calculating the influence of RF in the shack. It'll penetrate your skin, by the way. It warms it up is what it does, as I understand it. There's a really cool internet site called Ham Radio School. So that's pretty hard to remember. hamradioschool.com. And they have a real nice presentation in there on that site on how to do a base station or a mobile station RF safety check, okay? And if you're mobiling, avoid distracted driving. I know a lot of people have a difficult time talking on the radio, texting, and doing emails at the same time. I know other people are trying it, but you just don't want to do that, okay? So anyway, either station, you have a couple of essentials for operating, all right? Everybody pretty much knows what they are. A radio and an antenna. So if you have those, can you talk? Yes, you should be able to, but not always. You need one other item. Billy touched on it for a minute. You need propagation. If you don't have propagation, like he said, 10 meters is closed. Well, 10 meters, like I said, we had 16 check-ins with myself Monday night. And that same night, I noticed that there was a Brazilian station transmitting, and I tried to hear him, but I could not hear him. But you can find out how the propagation is on bands by doing several different things. One is there's broadcast beacons around the world on different bands, and you can listen to see where your propagation is good. That's one way. Okay, we'll talk about just a couple of ways of doing that in a minute when we get to the propagation. First, we're going to talk about radios. And to me, there's three basic levels of radios: entry level, mid-level, and of course, the high-end equipment, which is out of my range. If it's in yours and you're buying a new radio, then you want to throw a lot of money into the hobby, you can do it. I put those in the, above 4,000, 5,000, 6,000, or even on up category. The mid-range is in between that, and the entry level, of course, are the less expensive equipment. So if you're new to the hobby, and Billy's mentioned in the past, you might want to go used and then build up as you learn how to do some radios. We'll talk about what I think is a good way to start your approach to buy a radio. But you can buy all different kinds of radios. And some people stick with one brand. I've owned all these, but the Elecraft. And the Elecraft is a very, very good radio. And I have a lot of friends that run them, and I'd have one in a heartbeat. But the pros for staying within the same brand, whether it's Kenwood, Yaesu, or ICOM, any of them, is that if you change models, there's a lot of similarities, so the learning curve is less. If you switch around a lot, like I do, I'm not married to any one of them, I have them all, is that the basic functions of the radios are the same, but when you get into the advanced settings and want to do particular things, then it might not come right to you as quickly. And so then you have to consult the manuals, which is not a bad thing to do. So, but for new hams, and as well as anyone looking for a radio, I think the one is that fits your needs the best. That's the key to it, okay? So the radios, they have two basic functions: transmit and receive, of course, all right? And years ago, we used to have a transmitter and then a receiver, two different units, and today most of them are transceivers that we know on the markets today. So, so what does it make to make a radio spatial? Now, hams are very, very opinionated, okay? And tonight I'm talking, so you get my opinion, and that's the way we are. We may agree or we may disagree, but at least it's an opinion, okay? So before I go, I want to say 100 watts to an antenna is 100 watts to an antenna. What do I mean by that? If you have a radio and theoretically you're putting out 100 watts to an antenna, and you have another radio and theoretically you're putting out 100 watts to the antenna, the antenna doesn't know the difference between the two radios, nor does the guy on the other end, unless you've gotten sloppy with the microphone and the other settings. But theoretically, it would be the same. So what, in my opinion, is what really separates radios is the receive section. If you can't hear them, there's no way you're going to be able to work them, okay? So it separates the good and the bad and the ugly, all right? So really, the key to, from what I say, is pick it on the receiver section first. Now you have to consider other things, but this is where I would begin, okay? And so how do we know which receivers receive better? Well, we look at the specifications. And for somebody that's really been in the hobby a long time or very technically oriented, you can look at the specifications and you can figure out which ones are the best. Now, when you do that, you're going to see a lot of engineering data, and a lot of it, like me, it may go over your head. So what do we do then? Well, there's a site you can go to, as with everything, Sherwood Engineering. It's a great site. This is the web page you could go to. If you don't get this, then you can go out and Google ham radio test, receiver testing data, and it'll pop up. So what do you get when you go and check out Sherwood Engineering? You get a graph with, like I said, this is harder to see than I thought it would be. I apologize for that. First time presenting for NOFARS. But you get a column here, it's got a lot of information in it, okay? And it has noise floors, and you can check them all out, and it'll give radios in the columns down here, and there probably is 100 to 150 radios in that column that they've evaluated. And they have the evaluation for older radios as well as the newer radios. Yeah, thanks. That's all right. Yeah. Okay. That'll probably screw me up, but okay. Yeah, go ahead and reduce it a little. Okay. But you can see when Rajesh blew that up, let's not worry about the noise floor and that, but you can see what you're looking at, okay? But the key is here, the radio number 1, radio number 2, and I didn't put the brands on there, but it's interesting to find out which ones. Those are basically the higher dollar ones. But what you do is you go out on the internet, look at the radios in your budget, I would, and then come into this table and see where all those radios fall in there, and that'll help you choose it, as well as the other functions on the transmit side that you get back into. But the number one thing you want to do is have a radio that'll separate the signal from the noise. Okay, and in propagation, I'll show you a little bit about what the noise level is. If you've been on HF and you hear background noise, and it sounds like atmospheric noise, or some people call it frying bacon, that's the noise level. And if there's a signal in there, you need to be able to separate it, okay? Signal to noise ratio, to separation of it. So let's talk a little bit about the antennas. Again, there's just a lot of the subjects. You could talk about these for one night on antennas, which some have, but this is considered by most people the most important part of your station. Because if your antenna is not efficient, you're not putting out the signal that you think you're putting out, okay? So that's what you want to strive for. And the way I look at it is every installation is a compromise. And what do I mean by that? Well, a lot of us live on city blocks, and something is compromising our antennas on our city blocks. We're limited in space. The young man that serves in the Navy, if he was out on the ship in the middle of the ocean, that's pretty nice. You've got a metal ship out there for a good ground plane, and they can put off a good signal off of a ship. I have friends that have done that with HF radios quite nicely. But here in the city, trees interfere, buildings interfere, and other things. You have more noise in the city than you would in the country. The ideal condition would be on top of a mountain, but we can't do that. Or you put a tower up 100 foot. And a lot of us are limited and we can't do that. So we have to work within the compromises. You'd be surprised at how much changing a vertical antenna from one location in your yard to the other may change your signal. So you got, I don't know how this got messed up on your system where it wasn't on mine, but anyway, the idea, I'm going to pass up on that. You got all kinds of antennas out there that you can buy. But the fun part of the hobby is making your own. And like Billy said, you can throw up a wire and with a little bit of practice, get it tuned well and get on the air. Now, to make it efficient, you need to get yourself a good antenna handbook and look at how to build them to make them efficient. Because if they're not efficient and you're transmitting with 100 watts, your signal's not going to be 100 watts because you have loss between your radio and the antenna based on a lot of factors. One of them is line loss. So if you're not efficient, you're not going to transmit the best signal that your radio is capable of transmitting. So you want it to be efficient. All right. So in installing antennas, and this I'm going to go into some in the mobile installation in here that's important and show you the similarities. But location is important, as we just spoke. And then also a solid mount. If you tie an antenna to your house and it's not solid in our high winds, it'll come down. And if you put it up into a tree and it's not solidly mounted on a good limb, where if it's on a branch, it could come down. And if you don't install it properly, in other words, if you stretch it, the trees are going to move. And if they're moving, something's got to give. So you can spend a lot of time repairing them, but if you solidly mount them, you'll spend less time. Okay, grounding is important. You have to have a ground system for like vertical antennas. A dipole works with a ground plane out from it. It has two elements. One is working as the ground, the other is as the resonator. It's the way dipoles work, whether you put it horizontal or vertical, that's the way they work. If you use a vertical antenna, then you need a good ground plane under it. And you've seen on the net, or if you've researched any about verticals, the ground plane underneath it is as much as an important part of the antenna as the resonator. So it's got to be grounded well. And in mobile operation, if you want the most efficient mobile operation, you need to bond it well. And we'll touch on that in a bit. And the results of these things, this is interesting. This happens in the base station as well as the mobile station. And what can happen is you can create common mode current. And if you get common mode current, you're going to have a bunch of issues, okay? You're going to have losses in your signal. And you can, this is probably the #1 reason for mobile installations to fail. I talk a lot on the mobile rig that I have, and I've heard people say, well, I've tried that before and it didn't work. Well, why didn't it work? Well, they didn't make it efficient because they could have, okay? And it results in big RF issues, okay? Let me show you how that happens. This is a piece of coax that we've got a cut section in. And of course is the outer jacket. And then you have the outer braid. And you also have the insulator to protect between the center conductor and the outer braid, because you don't want electrical continuity between those two. Otherwise you'll burn up your transmitter, basically, is what you'll do. All right, so that's what happens. If you put RF in here, this is what happens to your RF when it goes to the antenna from the rig. It travels on the outside of the center conductor, not like AC that goes through the center. It travels on the outside. And you must size that conductor for the wattage that you're putting through that antenna cable, okay? And then the current returns, interestingly enough, on the inside of the outer braid, okay? So that's how it operates. However, if you have common mode current, then it's on the outside of the braid, between the jacket and the outside of the braid, and you can get RF shocks and RF all over. And that is the reason why a lot of mobile stations fail. It's not as important in 2 meter and FM, but it is important there. You can get it there, but it happens more on HF. But if you have it, you're losing signal, pure and simple. And in a mobile station, you could have it in your station, and you don't want it in there. So again, you need to do an RF evaluation. I've done that on my station, and I run sometimes 400 watts, 500 watts in my mobile station, and the amount of RF in the cabin of my truck is less than my cell phone measured on an RF meter. So that's a good deal, but you need to know about that. Let's talk. Go ahead.
What would be a reason that would cause the RF to reduce on the outside of the braid? Would it be a bad piece of wire, or would it be a bad connector?
Most likely grounding. Grounding is the main cause of it. Loose connectors. Anybody else have any input on that? But probably grounding is I think the
bad match overall.
Say it again.
Just a bad match.
Yeah, and a bad match. Thanks, Billy. I knew I was missing something. That's true.
So it's good to stick with 52 ohms.
Yeah, if you're not, if the impedance is not right, it's going to be as well. But it's something. Actually, they have meters that will measure that. I forgot I have one. But you can put that on the outside of your coax and measure how much is coming back in. They're not that expensive. All kinds of test equipment out there to assist ham radio operators. Don't overlook a lot of it. A lot of it is good stuff. Again, I think buyer beware. But we all know kind of how propagation works, and if you don't, this is the way it skips off the ionosphere. Sorry. And so you can see with the shows two ionospheres, and there is double propagation on each lower and upper, and then one singular down below. I guess two singulars. But anyway, sometimes we refer to this as back. We'll go into that in a minute. Sometimes we refer to this as short skip and long skip. If you're on the HF bands in like 40 meters, it'll change over time, and you can actually hear it changing on the band if you're on and you know where a bunch of stations are located, they'll fade in and out. And so it changes, like on nets. If you're on a net and you know where the other operators are located, then and nets are a very good way to test your antenna. You can see your propagation and know where it's going. That's an excellent way. To compare antennas, you have to do an antenna shootout, okay? You have to have them to the same equipment in the same general area, and then propagate on both of them, transmit on both of them, to see how the propagation is to a certain point. That's how you can do an antenna shootout. Okay, enough on that. If you want to know what's happening, and Billy mentioned a little bit on the solar indexes and that, this is on QRZ's page. And I'm sure most all of us have been on QRZ, and you see a lot of information here. Again, it gets pretty technical. Solar flex index, K values. There's a lot of information in here, but they've set this up for a quick peek. You can see that these bands are basically closed. That means there's no propagation. You're not going to really want to waste your time on them. These here are poor, and then you can see these bands are fair to good, fair. And so that's a quick look. But take all that with a grain of salt. The best, if you want to check it, get on the air and find out for yourself. And we all know that this all happens around the sunspots. We're in cycle 24, actually in cycle 25 now, and Billy mentioned it. 24 was bad, the worst one I've ever seen it. So they all got to get better from here. Okay, so you can go out there and find this chart as well, and this sums it up in a graph where you can visually see how good the band is. And over on the left column, that's the sun numbers, sunspot numbers, and you can see right next to it the SFI, or solar flex index. And you can see that the higher the numbers, the better the band conditions. So green light, better band conditions. Red light, it's poor. Okay? Contrary-wise, when you go over to the other side and you see the AP and the K index, the lower numbers are better. This quiet, that's the noise ratio down there, and it was given an indication on this chart with the noise level here. Now, what's given here is their measurements. It may not be indicative of what's in your shack, because you've got interferences from neighbors, from things in your own home, so it's usually a bit higher than that. But one of our operators, Mike, KM4KKS, has a light, he's near a park, and they have a softball field there. And there's a light every once in a while goes off in there, and on 10 meters, his S meter is 20 over, so he's not hearing anybody. He can't talk on it. So then he has to call JEA, and that's interfering with his station. And that's actually a fine that can happen to JEA. Anyone that interferes with our amateur radio stations can be fined by the FCC. Now, it's a lengthy process, but you can do it, and there are a lot of people getting fined, going out and putting out malicious transmissions and that. It's happened.
The reverse is also true.
Go ahead, Jack.
The reverse is also true. We interfere with other services. We can.
Yes, that is true. If you, thanks, Jack. But it's you can monitor your station pretty closely. But a fluorescent light tube going off in this church and the hams next door, the church can be fined. It's usually not the fluorescent light; it's the ballast that goes out. So, but it does happen. But this is a quick look that you can take if you want to know what kind of propagation you have. Again, even if it's, you go back to that chart I showed you before, and the SFI I think was 71, so it's just here at the bottom, but that can be pretty good. All right, so go out and try it. That's a good way. Let's see what time it is. We're getting. Let me go through this pretty quickly. This is my station, and this is my first station, and it's back a few years, 1971. That's a DX40 and an SX146 holocrafters. Holocrafters, pretty good receiver. Those are, but that wasn't one of their better models, but it sufficed for me. And that DX was tuned up on a light bulb. That's how I got it going. Right now I'm running a 6400 and a Kenwood 2000 for a backup radio. And that also is my FM radio I've got a couple of others, but that's my workhorse. My antenna, my main antenna is a ZS6 BKW. It's a knockoff of a G5 RV. I've got it at 45 feet, and it's good on the bands that are listed. It will not do 15, but on those bands, unlike the G5 RV, you tune it, and what makes it different is the ladder line length. And this antenna is resonant on all those bands. No antenna tuner needed. Now, you can't do 15, but my vertical will, but I can do 80 with a tuner. And I do have a tuner. And
Is that,
yeah, how's this happening, Rajesh?
what's that?
Screen resolution? This came right in on top of it. That's the first one that's happened to.
That's weird. Yeah, I guess it's a screen resolution problem.
That was a different one.
Oh.
Anyway, that's all right. We're going. What's shown there at 35 feet is my 2-meter antenna, and it's a Diamond X700H. That's the 23 feet in length, I believe, 23 or 24. It's the longest 2-meter antenna that you can purchase, I believe. It's from Diamond. It works extremely well. Oh no, that's the one below. The other one was my 10-meter, I believe. Yeah, it had to be my 10-meter. Nope. Yep. Now I got a Cushcraft beam. Sorry about that. What you didn't see was my AR10 10-meter beam, or 10-meter vertical, and it's up at 35 feet. Could be a little bit higher to be better for the 10-meter net, but that's the height of the pole. These are the two amplifiers, and I never had an amplifier until cycle 24. But those I got just so I could talk to a lot of friends that were on nets with me. That's my tuner. If I get some doubling here. Yeah. That's a watt meter for monitoring my, that's a PALSTAR watt meter. And then I have a cheapie on the 2-meter side. I don't really, I know my wattage out of my radio. I measure it another way. All I want to make sure is my SWR doesn't go up. Net suffices for that. Okay, there's my station. This is the Flex. You can see it's got a nice waterfall in it. This is totally standalone. Although it's an SDR radio, it's totally standalone. And as you can see, well, it's hard to see there, but there's a lot of knobs besides the menu driven. Of course, a lot of them anymore are menu driven. The 2000 is there. There's a 45 amp power supply that powers the station. And I've switched these out for $20 30 amp switching power supplies off of Amazon that they use in computers that work very nice for amateur radios. The fans are not real noisy, but put out a little bit of noise, but so does that one. Those are high dollar radios. That's 45 amps because my other radio that I bring in at 200 watts pulls 30 or 35 in the mobile. I'll show that to you. And this is the best thing I ever did in a shack was pull it away from the wall just as a hint, because I can walk back there and get behind and take care of everything. So that was one thing I did. I just wanted to point this out, and that this electrical panel is through the wall into the shack. This is where I enter. As you can see, I do all the feed lines in underneath. And you can see I use a lot of grounding braid, not wire. And on this one, you can see the braid better here. The coax goes underneath, but this is the 8-foot copper ground rod. And this is coaxial cabinet connectors that I've mounted on a copper pipe on that ground rod. And so during lightning, I just simply unhook them off the shack, put them on the coax connectors over here, and I'm out of the lightning. Now that doesn't take care of all the lightning into the shack, because if you don't unhook your radios, lightning can come in through the ground plane of your home. And so into your, well, first would go into what? Your power supplies, okay? It'll take out any amplifiers or anything's plugged into the ground. So I basically unplug my computers and all my equipment out of the AC will basically have disconnects. Okay, a little quick pick, I'll show you my antennas. That's the 700 H, that's the 2 meter at 45 feet. Dipole right up with it. And there's the AR-10, hard to see on that screen. And then you can see my 2 meter beam pointing north. That's for, I use on simplex only for DXing when it's open. Here's a great site to go to. You want to know about mobile installations. This guy's got a lot of technical information and a lot of good things on different things. For example, ferrite core chokes are not all created equal. There are different formulations for different frequencies. So if you're wanting to choke something, whether it be in your house or whether it be on your equipment, keeping RF from going into your equipment, you need to put those on according to frequency.
One thing very important about those shows is trying to make sure you don't get RF energy into computer cables to mess up your computers. Like the VGA cable or the keyboard cable if you don't have a wireless keyboard and so on and so forth.
Yeah, this is a choke right here on all your computers, or at least most of them. You have a choke.
It gets rid of the common mode.
Say it again?
It gets rid of the common
It
mode.
does. It does. You're going to have some of it, aren't you? But you don't want the worst end of it, right? Because you're losing everything, right, Henry? You don't want to lose your signal. You paid a lot of money for the equipment, put a lot of time in putting it all together, and putting the antennas up. Why lose it in common mode current, right? Simple air choke will work on a lot of it if it's installed properly. There's my radio in the truck. And what time you want me to quit, Roger?
Whenever you're ready.
These guys are ready for me to run out of here now. Okay. I'll go through it. This some of you have seen this, and I didn't like how this happened, Raj. We got to correct that. There's my first station. I ran that for 12 years. Then this is my next one. I'll show you my Scorpion 680. I like it, as most of you know. There it is, and I mounted it back there. Actually, the best place to mount radios in a truck are center mass, right there. But as you can see, this would be too big there. Next good place is right here, or center of the bed, raised, okay? Where do you think the worst place is to mount an antenna on a mobile station?
On your steering.
On your trailer hitch. Right there, that's the worst place. Go down to Hamcation and see how many you see down there on the trailer hitch. They're losing a lot of signal, I'm sure. But they'll work. They'll all work. Okay, and this is what I do when I'm traveling. Most all my HF work is done stationary anymore. Go ahead.
One thing I noticed on your truck, you follow the principles of Walter Maxwell. He was a great hammer and did a lot of antennas and stuff. And he said that when you're running HF, and it's hard for him to understand this, your signal radiates from the bottom of your antenna. And like he said, you put it down your bumper, you're killing your signal. You need to get that at the bottom of your antenna.
Yeah.
Above the lowest part of your vehicle.
Exactly. Exactly.
That's exactly what he has it.
And it is a compromise, and again, on the mobile stations, they're all somewhat of a compromise, as with base stations, in my opinion. That I made myself, this mount, And then in this truck, it's an aluminum truck, by the way, so I didn't do as much bonding in here as I did the one before that, which was a Dodge. I bonded with those grounding straps, the tailgate, the hood, the doors, everything, so that it all be one tin can. Because mobile operation in itself is a compromise in that you don't have as good a ground plane as you really need, but you can make it work well.
It also affects the noise level on the seat. Tremendously.
Right, exactly right. I put 2 punctures in my truck, and I'll show you quickly what they are, but one of them was in here for the cables to run underneath. I went through the wheel well down in. When I get done with this truck, I will simply have a hole in the side like this. This is a sprayed on base. I'll plug it with just a plastic thing and you won't know it was there. Just quickly in the cab, this is what I have. There's my radio. You can see how big the Palstar is, but I love it. It's very accurate. And DSP, because my hearing isn't what it used to be in the 4th quarter, Herb. And that is my amp controller. And this is probably my most important piece of equipment. So I know what my battery level is. You don't want to run it out or you won't be moving the vehicle. That's just a side view. And there's where I keep my antenna controller. This is what it looks like.
Let me ask you a question.
Sure.
I have a new automobile, and I've been looking into the electronics of the automobile.
Okay.
And all new automobiles are just overwhelmed with computers.
Yep.
Not only that, they use the main computer to monitor the current.
Yep, I'm going to get to that.
And so my first question, we talked about common mode current, but my big worry, even with a 2-meter rig, is, all these microprocessors, the body module, all of these things are expensive.
Yeah.
If you key that microphone, you run the risk of taking these things out.
Yep. Yeah, you want it installed properly, and it needs to be. I'll show you real quickly how I did that. Well, this slide shows it. Okay, there's the battery. Just quickly, the positive comes right off the positive. Now this, remember, there's 2 pieces of equipment in there running over 30 amps. So each one of these will handle 60 amp because you can have line losses in that. I overkill everything. It's probably a bit much. But there's 2 fuses right here. That's on the positive, as well as 2 fuses right here on the negative. Now you can see this negative does not go to the battery, okay? Because this is for design. They tell you don't take it to the battery. Why is that? Well, they got a little gizmo right there, and it encapsulates the ground wires, okay? And what that does, it's feeding information to the computer. And if you mess with that, your car's not going to run right. These things are just like your home computers. Once in a while, you got to turn them off, turn them back on to make them run right. Go, Steve.
I install radios for a living, thousands of them. The key thing is never use your battery as a source for ground. Always get rid of a fuse in any ground you have. Make it as short as possible. Go directly to the frame or the body of the car. And one most important thing, if anything, is to use a star washer. Where I worked at, if you didn't use a star washer, you lost your job doing the grounding. Don't use your ground. If you check all that ground wire and run all the way to the battery, you just created a radiator for your car. Like Henry said, through your electronics and stuff like that. You create all these loops and stuff like that. You want that sucker short.
Well, the thing about it is, that little thing you're talking about is called a Hall effect sensor. And it's used to measure current.
Yes.
And the electronic control module knows what all the currents are going to all the modules.
That's correct.
And if you all of a sudden, if this doesn't add up and you're drawing current from the battery and the ECM doesn't know it, it's going to throw a code.
Right. And they call it something different. I forget what they call that. There was an acronym for it. That one. But listen to this. This is blessed by Ford. I took it back over to the dealer and said, "This is what I've done. and I want one of your specialists to look at my electrical setup. And he came out and blessed it. But he did tell me something that was very interesting. And he says, I said, I did this according to Ford's manual. And he said, that's what they say to do. But he says, I don't believe it. He says, if you would have run off the battery, he says, I think that the computer would have compensated for that and readjusted. He
Good night.